so let's talk about the situation first, okay? Jack took a drive in the country. He drove for a while, then stopped to buy gas. He drove a bit more and stopped at a roadside fruit stand. After more driving, he stopped for lunch, then he drove straight home. Okay? So here's kind of how I picture this. This is the time. So the further I get away from the origin, the longer he has been driving, right? So if this is hours, he's been driving 1 hour, 2 hours, 3 hours, 4 hours. So it looks like he was driving for 8 hours, or he was gone for 8 hours, I should say, right? And this is his distance away from home. So if I looked at hour 1, it looks like he's about 10 miles away from home, right? If I look there, actually it looks just a little bit before hour 1, correct? Why does it flatten out? Because he's stopped. He's not getting any further away from home and he's not getting any closer to home. So those flat places mean he's not doing anything. Or it could be one of his stops. So I would say, when did he stop at a roadside fruit stand? He stopped to buy gas. So I would say buying gas would be letter B, right? There's another stop at letter D. What was his second stop? The fruit stand. So I would say that letter D is his fruit stand stop. Does that make sense? Letter A was buying gas, so I'm going to go ahead and fill that one since I know. What was his other stop? What was F? Lunch. So again, why are those flat lines? Because when you're stopped, your distance, you're not getting further away from home while you're stopped. Like right now, you are not getting any further away from your house or any closer to your house. You are stopped. Okay? So that's why we get these flat lines. Okay? What about when he drove straight home? G. I like to think about the x-axis as home. When you're touching the x-axis, you are at home. So he starts at home, he ends at home. Okay? So I'm going to say part G, G is what talks about going home. What about when he started his drive? What would be the beginning of his drive? That would be that first part, right? That's where he's driving and then he stops to get gas. So that would be part A. So we're going to be looking at graphs like this. Question? That one's supposed to be B, isn't it? Thank you for catching me. Thank you for catching me. So we're going to be looking at graphs like that and interpreting them. That's why when I showed you your homework page, it looks like it's kind of several pages. But it's because they'll give you a story and a graph and ask you questions like this. Okay? All right. A couple definitions that we talked about on Friday. The domain. Does anyone remember what domain is? X values. What was the other word we talked about? Input. What about range? Output. Also known as the Y values. Okay? So if I talked about the domain of this graph, and I'm talking about the X values, I look at the X-axis. It looks like he starts his trip when the domain is what? 0. Time is 0 at the beginning of his trip, right? What is the time at the end of his trip? 8. So I would say X is between 0 and 8. I would say 0 is less than or equal to X is less than or equal to 8. That's how I would explain the domain. That means that the entire trip happens between 0 hours and 8 hours. So? How do you think I explain the range? Keep in mind, if domain is my X values, it's talking about hours. Range would be talking about miles, the Y-axis. Sorry, I'm off the screen there. So he starts off at home, right? Which means his distance from home is 0. He's there. And then how far away from home does he get? all the way to there. What would you say that is? About 45. So I would say 45 miles would be his max. So our y values are between 0 and 45 miles. So, kind of funky. Okay. Notice my symbols are always pointing this way. When I'm talking about domain and range, all of my symbols all have to mean this, which is less than or equal to. Okay. All right, so let's look at some graphs here. It says find the domain and the range, and I'll do that in just a minute. These are different types of graphs. Can you give me the two words that we talked about that made graphs look different like this? Discrete and continuous. Is number 8 discrete or continuous? Discrete. Remember, if it's continuous, I don't have to pick up my pencil if I'm drawing it. I have to pick up my pencil every single time on this, right? What about this one? Discrete or continuous? And this one? Continuous. My pencil doesn't have to be picked up. Okay? So let's talk about our domain here. For a discrete domain, I can't use this. This was a continuous graph, right? Because I could draw the whole graph without picking up my pencil. Okay? For a discrete graph, I have to just list the x values of those points. So I have the point 0, 0. I have the point 1, 1, 2, 2. Right? Do you see where I'm getting these from? 3, 3, 4, 4, and 5, 5. How do I get my domain from there? The x values. 0, 1, 2, 3, 4, 5. Why can't I just do this? Because this means that 1/2 could be an answer. Is there a point at x equals 1/2? 1/2, there's no point here. Right? So I can only use that for a continuous graph. Okay? What about if I didn't want to list the points? I wanted to just get the domain from there. How could I do that? I could just look at their x values. So 0, 1, 2, that one's at 3, 4, 5. I could get it from there as well. How about the range? It's the what? Y values. And I could get them from the points, or I could get them from 0, 1, 2, 3, 4, and 5. Does that kind of make sense? Domain and range is something it gets tricky at times, but we will continue to discuss it for a while. Okay? See if you can tell me the domain and range of number 9 here. Can you list the domain and the range? I love it when people are squinting to see it up there when it's in front of you too. It's the same graph that's on your paper. So if you don't want to squint and look up there for the numbers, you can look on your paper. Yes, sir. You got it? Okay, just hold on a minute. So I'm going to look, this point right here has an x value of 1. This point right here has an x value of 2. And then this one has 3. Do I have all the numbers? 4, 5, 6, 7, and 8. 3, 4, 5, 6, 7, 8. That's my domain. Make sense? Now let's look at y values, my range. This point has a y value of 3, right? This one has a y value of 6. This one has a y value of 9. This one's also 9. This one's also 3. There's no other y values except for 3, 6, and 9, right? They're just duplicated then. So that's the end of my range. Capiche? All right. Now, this one is a continuous graph, right? The word domain got cut off, didn't it? Sorry. Supposed to be asking for domain there. So on a continuous one, I have to write it using this inequality notation. Now, it is important to know when you are finding the domain if at the end there is an arrow or not. You've graphed lines before? Have you graphed lines before where there's arrows at the end? That affects your domain and range. So we're just going to assume that this one stops there at the ends. Okay? So if I'm talking about my x values, it starts at 0, and how far over does it go? This one I would say is what? 5.5 probably. So I'm going to say 0 is less than or equal to x is less than or equal to, we'll just say 5.5, or you could write 5.5, whatever. And this is the distance, or this direction we're talking about minutes. Okay. What do you think about range? Where's the lowest part of the graph? Starts off at 0, and then how high does it end up going? 11. To 11. So I'm going to say 0 is less than or equal to not x, because range we're talking about y is less than or equal to 11. And what is our range talking about? It's not talking about minutes, it's talking about feet. So? Let's turn the page. Okay. A person decides to go for a run, but must take breaks at certain points. The person's distance from the house is shown in the graph. Segment 1, right here, shows the person is moving away from the house. Because remember, I picture this like the wall of the house. They're away, getting further away. This is where they reach their furthest point from the house, right? Is the highest point. What does segment 2 show? Yes. Slight increase away from home. So they are still continuing to move away from home. Yes. What else does it show you? She's going slower. Yes, that's exactly right. Do you see how steep this is? That means that she's going pretty fast. As soon as it becomes less steep, she's not moving as quickly as far away. Does that kind of make sense? In other words, this would mean, like, let's say it was 30 minutes here and then this was an hour. That's a really long run. Let's say 15 minutes and 30 minutes. In 15 minutes, she got that far away from home. But in another 15 minutes, she only got maybe another half mile. So she slowed down a little bit. Slowed down. Okay. Based on the time frame, so in other words, not talking about her distance from home, but talking about the minutes, what does segment 5 represent? So let's look at what's happening in segment 5. It's fairly steep, so it seems like she's traveling fairly fast. But where's she going? Home. So I would say segment 5 is when what? She starts her return trip, right? She starts heading back home. Going home. Which line segment shows an interval where the distance did not change? 4. And when we're talking about distance, not changing, we're looking for a segment that is completely horizontal, right? So we're going to say segment 4 there. What is a possible explanation for that segment? What could have happened at that point in her run? She took a rest, she stopped and got some water. Maybe she made it to her friend's house and then she came back later. But she reached some kind of a destination and stopped, right? So she stopped running. Okay? All right, you take a minute and see what you can figure out with example 12. We've got another graph. See if you can answer A and B. So this guy's in the shower, and this is showing the depth of the water. So how deep is the water he's standing in? So they ask you to focus around 6 minutes. That's right around there. What seems to be happening there?
His drain is really big.
His drain might not be very efficient because it looks like it's building up a little bit of water. This says inches, so obviously it starts off empty. And as the water is going on, it builds up to about 2 inches deep. Sounds like you need some Drano, right? So what happens at 6 minutes then when it starts curving back around? It starts draining. He probably turned the shower off and is now letting the water drain, right? So what is happening? The depth is, what's happening to the depth? It's decreasing, right? It's increasing up to 6 minutes and then it starts decreasing. So he probably turned the shower off. Yes.
In this question, was it like what happens like before it was like 7 and 8? Doesn't that mean like before it starts declining? Because the second question is what happens after the 6 weeks?
As the time reaches. Yeah, what occurred after? Yeah, you're probably right. That would probably be a better explanation for that part. And what would we say is happening as it's going there? The water level is increasing up until then, right? Okay, so why is this not discrete? Why is it continuous and not discrete? Your pencil doesn't have to leave. Think about the situation. Can we change it to a bathtub because it's weirding me out that this isn't a shower?
Thank you.
Okay, because your shower should not be I need to clean that shower. So let's say you're filling up a bathtub. Okay, I have to do that for my son every night. Fill up his bathtub so he can go play with his toys and clean. What makes that continuous instead of discrete? It's not like the bathtub is 1 inch full and then miraculously it's immediately 2 inches full and then 3 inches full. It has a constant stream of water, so it's just slowly rising like this, right? It's not like stair-stepping up. That's what makes it continuous, okay? Think about your age is continuous because right now you are older than when I told you to think about your age 2 seconds ago, right? You are now older than you were 2 seconds ago. It's a constantly changing thing, right? So is your height until you reach your max height, and then you hang there until you get old, and then we all know you get shorter when you get older, right? So that's another continuous thing until the growing level stops, okay? So those are some continuous things. All right, now we have to sketch a graph. A bathtub, oh, thank goodness we're on a bathtub now. It's being filled with water. After 10 minutes, there are 75 quarts of water in the tub. Okay, so I know that at 10 minutes, 60, that would be 80. It's going to be right about there. Yeah? And I know that it is filling up. Hopefully it was empty, otherwise you're dealing with dirty water. So? Why do you think it's a straight line instead of a curve? Because I don't know about you, but when I fill my son's bathtub, I get it to the right temperature, and then I just leave it. I don't make the water go out any faster or any slower. Once I get the temperature, I just let it do its thing. So it's going at a constant rate into the bathtub. Okay, then somebody accidentally pulls the drain plug. Oh, crap. While the water is still running, and the tub begins to empty. So what's going to happen here? It's going to go down, right? It's not going to have 75 quarts anymore. The tub loses 15 quarts in 5 minutes. So what does that mean? What's 5 minutes later? At 15, we are now 15 quarts below where we were, which was 75. So where am I at 15 minutes? 60. So that's a steep little section. Okay, then somebody plugs the drain and the tub fills for 6 more minutes. So what direction are we going again? Up. Gaining another 45 quarts. Whew. Okay, so wait, where were we at? We were at 60. If we are adding 45 quarts, where are we at? 105 in 6 more minutes. So I was at 15, right? So now I'm at like 21 minutes. And we're like up here again. Does that kind of make sense? After a 15-minute bath. So what does that tell me? For 15 minutes, what's going on? The water level's not changing. Right? So I'm at 21 minutes right now. So what's 15 minutes after that? 36 minutes. So all the way to here, my water level is not changing for 15 minutes. That is definitely not my son's bath, because that's when he's splashing all the water out and driving me nuts. Okay. Then they pull the drain plug, and it takes 11 minutes for the tub to drain. So if I'm at 36 minutes there, 11 more minutes. So 47 minutes overall. That's like right here-ish. It's finally drained. That is the bathtub. So? Kind of crazy to think that that was a 15-minute bath, but it took 47 minutes from start to finish. Yeah. I can't visualize what 105 quarts looks like because I can't. We don't measure in quarts very much. That's hard to visualize, but whatever. Okay, last one. Is this one discrete or continuous? A local salesman is going door to door trying to sell vacuums. For every vacuum he sells, he makes $20. He can sell a maximum of 10 vacuums a day. I feel like this is 1950s. Who sells vacuums door to door? But whatever. Usually when somebody comes to your door, you're like, what do you need? Yeah. Is this continuous or is this discrete? Can he sell a half? No. So if he can't do a half, we have discrete. It's either 1 or 2 or 3 or 4, all the way up to how many can he sell in a day? 10. Okay, so let's go ahead and look at this. If he sells 0 vacuums, what's his profit? 0. If he sells 1 vacuum, what's his profit? $20. If he sells 2 vacuums, if he sells 3 vacuums, do you see a pattern? If he sells 4 vacuums, 5, 6, 7, 8, gosh, it's hard to follow those lines, 9, and, oh, hang on, I was a little off on 9 there. Whew. So he could earn $200 a day in profit, right? That's not too bad. We decided it was discrete. And why is it discrete? He can't sell half a vacuum. Right? Let's see. What do I want to ask about this? What is the domain for this graph? Kind of a pain to write, isn't it? What is the range for this graph? 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, and I'm really running out of room, 200, and close your squiggly. Whew! Let's go back to the previous one. I should have asked you then, but let's write the domain and range for the previous one. What would my domain be for the bathtub? So my domain starts at 0 minutes and it goes all the way to what? Didn't we get to 47 minutes?
Yes.
So 0 is less than or equal to x is less than or equal to 47, and we're talking about minutes. What would my range be? We starting at 0? Is less than or equal to y is less than or equal to what was the maximum amount of water? You remember how high it went? 105, and that one we are measuring in quarts. Okay? So? Okay. So I mentioned that the textbook page is on Google Classroom. You can just do your work on a separate piece of paper and then take a picture of that and turn it in. Okay? All right. Happy studying.